Welcome
to the joy of coding.
Hello, and welcome to episode 31 of The Joy of Coding. My name's Mike Conley, and I'm wearing a funny hat. Now, why am I wearing a funny hat, or wig? You might be wondering, and that's a great question. The reason for that is because I'm in a new room today, because of some sort of room conflicts, and for some reason, whenever, like, at certain angles, parts of me become transparent. I guess parts of me become green. Like, check this thing out that's going on with my hand right now. And that's also true for my forehead. If you check this out, my forehead, there's like this green splotch that's showing up. I don't know why. I'll probably not use this room again next week. I just realized that's what's going on, and I figured, especially whenever you've got, like, I don't know, some code with some dark background or something, then this blotch on my forehead can be pretty distracting. So I ran around and I found this wig, and hopefully this wig is less distracting than a blotch on my forehead. So I'm going to put this back on. There we go. And that's why I'm wearing a wig. So, what are we doing today? Good question. A couple of things haven't worked out properly today. No plans survives breakfast. I haven't actually put the agenda up yet, so let me do that real quick. But before I do that, let me just fill out what this stuff is. What are we going to be doing today? Today, we are going to be... Oh, hang on. I've also realized that my camera needs to be zoomed in a little bit more. Something is up with, like, the dimensions of my camera. One moment. 480. Something is going on here with the cropping on my video stream. Nope. Just 1 second. Bear with me. I want to crop 30 pixels, 30 pixels, 50 pixels. I know settings. What are we gonna do? Sorry about that. Sorry about that crash. Wow, things are going all wrong today. So what I'm going to do is double check that sound is working. Yay! And now, in order to fix the camera, because I've got these two dark bars above and below me. I don't know if you can see this in the corner. I don't recall having this. Whenever I was sort of setting things up. So this is a bit of a surprise. I apologize. Hey, all right. I think that's more like it. Something went up. Something was up with OBS. I apologize for that. I appear to have corrected it, and sorry for the crash. If you're watching the recording of this, the first half of the video, I guess, is gone. I don't know if it's still around. Maybe I can sew both pieces together. Oh yeah, there are two videos here. Maybe I can sew them together, but yeah, it did not go according to plan. Anyway, that's alright. Now we can get to work. So, stuff. What are we doing today? Let's stop screwing around with OBS and get to work. What are we doing? Today, I'm working on this bug. Bug 1209689. So I'm going to update the agenda. I know I haven't put the link to the agenda in the video, like, description thing on AirMozilla yet. So you get to watch me do that. And let's do that. So, what do I want to do? I want to copy this. I'm going to put that in here. And then my notes, links. I've got my notes here. I'm going to copy the public link and put it here, over here. And then I'm going to, what am I going to do? That's it. That's really all I wanted to do. So now I can copy the public link, and I will now put it in the AirMozilla video bits. we're on episode 31. I'm about to visit my... So if I were to click on this and activate the stream, I could watch myself. Isn't that amazing? So I'm going to edit the event data and throw the agenda down up in here. There you go. So if you're missing the agenda, you might actually have to reload the page, and then it'll be like right down here, right here in additional links. You can click on the agenda. Okay, so that was a lot of sort of rigmarole to get us to the start, to actually hacking on stuff. So what are we doing? So what is this bug? Bug 1209689. Oh, hold on. Before I do that, I want to give a quick update on another bug that we were working on last week. Last week's episode had a lot to do with this option bubbling thing that I kept dealing with off and on and off and on. I wasn't sure what to do about it, and I was getting really, really frustrated. And the notes were copious and copious and copious. And what I ended up doing with this bug is realizing that the behavior that is expected from the browser is unclear. There is not a whole lot of there's no specification for what the browser is supposed to do in terms of firing events for option elements. And so I filed bugs with the wattwg and the w3c to get that kind of hammered out in the spec. But in the meantime, because this is not likely going to be a web compatibility breaking change, the fact that we do not bubble up these events, we sort of deprioritized the bug. Because the only reason it was a high priority is because we thought we were breaking web compatibility, and that's no longer the case because there's undefined behavior or unspecified behavior for option events coming up through dropdowns. So hopefully when the W3C or the wattwg or whoever figures out what's supposed to happen and that gets hammered out, we can sort of implement the right thing. Because right now all the browsers do different things. And if you're interested in reading about all those different things that they do, check out comment 27 in this bug, because I did a quick study on what each browser does. Okay, so what are we doing now? This is what I wanted to work on today. So crash tab indicates all tabs have crashed, and every tab loads the crash tab page. What does that mean? Well, let me show you. And I've already started working on this bug, and I've got some like experimental stuff, and I've got a couple of ideas on how to deal with it. Yeah, let me revert that thing. And I'm going to use mock build faster. I've got this like, I've aliased MBF to be mock build faster. Mock build faster is this new thing that we have that Glandium, who might be watching this video, thank you so much Glandium, he's built, maybe with some other people, that makes building the front-end code much, much faster. Like, look at this. This only took 16 seconds, and most of that was probably spent reticulating splines. But if I did that, that's because probably something in the Moz build or maybe a test file changed. But, like, if I just, like, right off the cuff, MBF, 2.85 seconds, and all the front-end code is linked is like symlinked and set up properly, that's pretty good. What I'm going to do, though, is get rid of the fixes that I've put on top so I can demonstrate the problem to you. MBF. Oh, it's got to reticulate splines again. And then mconley is my other alias for just opening up browser in E10S mode. Okay, so I've got all of these. Let's show what happens whenever this bug rears its head. Let's go to a couple of websites, go to my own blog, let's see what I'm saying on Twitter, all sorts of stuff. So here are a bunch of websites. Now I'm going to restart the browser. And you may or may not know this, but when the browser starts up and restores, like by default, Firefox will attempt to restore your previous session, so all of your old tabs and stuff. But one of the things you might not know, or maybe you never really thought about, was the fact that these background tabs don't actually start loading until you choose them. So for example, this CBC website tab loaded because it was the one that was selected, but all of these background tabs, if I were to click on them, Now they load. Like you saw the spinner, and then it loaded the page, and at first it was blank, and then it loaded. And that's a performance optimization. That's a way of making sure that we're not, like, if the user restores 100 tabs, that we're not spending loads and loads of time downloading all of the background tab stuff. And now instead we kind of lazily, we load them on demand, and that's a performance optimization. That was a big deal when that came out. I think that was Firefox 4. Or maybe it's 3.6. I don't remember, but that was a pretty big deal. So what is this bug about? This bug has to do with those unrestored tabs sitting in the background waiting to load. If you crash the content process, if the content process crashes, we crash these unrestored tabs as well. And that's kind of dumb, because like these weren't actually doing anything. They weren't actually, like, they hadn't loaded anything. So why did they crash? Like, why did they need to crash in the first place? And when I restore them all, they go back into the unrestored states that when I click on them, we actually do the restore. So why would they have crashed? They didn't have any content in them. And it's also really bad if you have like 100 tabs or 150 or 200 tabs or whatnot, and then you crash the content process, and then all of those tabs have to go into the crash tab state. Wouldn't it be better if we only crashed the tabs that were actually loaded? And for the ones that aren't loaded, whenever you click on them, we just do the thing where you restore the tab. That's a way better idea, and that's what this bug's all about. And it's a lot harder than you'd think to do that. I've written a regression test to make sure that we get the behavior right, where you can crash the main tab, but the unrestored one isn't crashed, and et cetera, et cetera. But getting the actual bug to be fixed has turned out to be harder than I thought. And this has to do with, there are a couple of like underlying assumptions of what's going on whenever the browser starts up in ETNS mode and restores a bunch of tabs. And this is good for me because it allows me to vocalize and explain what's happening, and then maybe I can see a way forward. I haven't actually, all of this code has to do with a component of Firefox called Session Store. Session Store is the thing that remembers where you've been. Like it's not your bookmarks and it's not your history, but it's your session where, like, if Firefox crashes or if you restart Firefox, it remembers state of all your browser tabs and like where they were, whether or not they had back forward history and where, and like what forms had been filled out or whatnot. And then when you restore, it tries to restore all of that stuff. And so that's great. But it also means that Session Store is pretty complicated. And there's a lot going on in there. And part of the struggle of fixing this bug is understanding how Session Store works. And maybe, if we work together, we can figure it out together. So, MBF. So where am I? What's my proposed solution? My proposed solution is to have those background tabs that have not yet been restored, to have them not be remote. So that they don't actually have the capability of crashing. They're just background browsers that are running in the main browser process, but they don't have anything in them. They're just about blank or whatever. But as soon as we select the tab, when we choose to restore its content, that's when we flip the remoteness. That's when we choose to restore the content in it. And that way, if you have a bunch of unrestored tabs, and the content process crashes, well, then those unrestored tabs shouldn't crash. And I'll demonstrate where I've gotten with that, because I actually have that working. mgo is another alias I've created that will do the mock build faster, and then it will just run my profile. Okay, so this has my patch, and so what I'm going to do is these three background tabs are unrestored. I'm going to crash the browser process, and notice I crashed the content process. The background tabs did not crash, and if I were to select one, they restore. That's what we want. This is the desired behavior, and this is great. This is exactly what we want. And then we restore this tab, and we're all good. Like this is what we wanted. But there are problems with this approach. I've got a number of test failures. And the reason I have test failures is because I've broken some stuff. Specifically, I've introduced in certain tests a race, or I've exposed a race that can occur. No, I've introduced a race. And that has to do with the fact that some of our tests will have an unrestored tab in the background and then try and load something in it immediately that causes certain... What am I trying to say? We flip the remoteness too quickly in my current patch. We flip the remoteness... not too quickly. I guess this is my way of demonstrating that I don't fully understand the problem. I think I should just come right out and say it. I've got this solution, and I'll show you the patches. I've got this solution, but the solution regresses some tests, or causes some tests to break, and I haven't fully understood why yet. And I'm starting to get into it, and hopefully I'll be able to understand it soon. But I don't fully understand it yet. So here's how the patch works. When a browser crashes, when we start to revive the browser, we remove the crashed attribute from the tab, we send the browser to about blank, and then we choose to restore the tab. And that way, if you restore any background crash tabs, if they had been restored, whenever you click on them to restore lazily, we don't see a flash of the About tab crash page. There should just be showing About blank. What else do we do? I make it so that any tabs that are restored when we restore a window, that they all point at About blank and are not remote. That's the other thing. And then the last thing is, we don't flip the remoteness of the browser whenever we restore a tab, unless we're supposed to be restoring the tab immediately, like restoring the content as well, or if the browser that we're looking at is currently the selected one. And that's when we update the remoteness. And this is the problem. This thing is what's introducing all of the test failures. If I revert this, all of the test failures go away. And why is that? What is going on? I wrote down some notes here, because I think I figured it out. The problem with... So one of the tests that failed was test 46, this browser underscore 463205, which I will bring up. I probably actually already have it open, 463205, right here. It's a very small test. The problem here, I wrote, is that this test seems to be the transition, seems to exercise... No. The problem here seems to involve the transition from remote to non-remote tabs. So we start the test by opening up an About blank tab, which will run in a remote tab in E10S, and then we restore the tab to a Chrome URL, which makes it non-remote, because Chrome URLs are blacklisted. They can't normally, for the most part, I think by default, Chrome URLs are not loaded in the content process, they're loaded in the parent process. And when we do that, we fail to restore fields in the form in that Chrome URL properly. And it looks like it might be some kind of race, and I'm reasonably certain it is. So I broke it down to smaller steps. A background tab browser starts remote, and then the background tab browser is restored to a non-remote page, this is the Chrome URL, with some form history. But whenever we choose that tab, when we actually restore the tab, the form history is not properly filled out. And I identified this block of code as what's introducing the problem. And what else did I write? The problem is because we do the remoteness switch, but after the point where we've queued a message to the page, so it gets cut off, and that's why the form history stuff doesn't show up. I think what I meant was over here in the restore tab method. Down here, so notice we do the update browser remoteness over here for just the one. Let's pretend we're looking at a tab or a browser that's in the background that is unrestored. And what we do is we don't update the remoteness, so it continues to be whatever it's supposed to be. In this case, it's going to be non-remote with my patch. Yeah, it starts out non-remote. Is that true? No, that's probably false because we add the tab. In this case, we're adding a tab at about blank. We're not restoring a tab. We add a tab at about blank. So the browser starts out as remote. So the browser starting out as remote. We don't do this step because we didn't say restore immediately, and when we add tab, we don't switch focus to it. It's just loading in the background. So we skip this step. So this remote tab is, and the URI in this case is like some Chrome URI. It's like Chrome : / some path to some test HTML file. So this browser is supposed to be non-remote whenever we resolve that URI, but we haven't gotten there yet. So it's still remote. And we do all this like messaging setup, and we send a message with the history of the browser, and that includes things like form data and all the stuff needed in order to like restore the form data, because that's what we're exercising here, is restoring the form data. We send it down, and then the page, I believe, starts to, in restoring the history, and then I believe we attempt to actually restore the content. I believe that's what happens next, because I don't know why, but let's suppose that's what happens next, because we are trying to restore, like it does load stuff. It doesn't just sit there in the background unloaded. So it does load stuff, and in doing so, the doc shell inside the content process says, I can't load this URI. This is a Chrome URI inside the remote browser. And so it sends up a message to the parent saying, this is the wrong one. The parent flips the remoteness of the browser and attempts to like restore history in the browser again. It's clear that I don't fully understand Session Store. If there's anything that's coming out of me babbling like this, it's that I don't really fully understand it, and it's complex. Like, it's nicely documented, and the code itself is quite clean, but it's doing a lot of stuff. Its responsibilities are pretty complex, and there are lots of pieces to Session Store. Like, if we look under Browser, Components, Session Store, there's so many parts to it. Lots of JSMs, workers, and state, and cache, and flusher, and the Session Store, and storage, and saver, and migration, and like so much stuff. For what is essentially just maintaining state. And I say just, but that's a weasel word. It's a complicated problem. That's why it's got a complicated solution. But maybe I need to better understand why this technique is not working. I feel like I had a formulation, but I really need to like deeply understand it for this one test failure. And these were the other test failures. I haven't even gotten there yet. I want to fully understand the test failure in... And then I had a conversation with Mossip. I want to fully understand this test failure. So I'm going to do this by adding some logging, because whenever I added a debug statements like breakpoints, I believe what happened was the test passed, which usually that's an indication of a race, and so I don't want the race to affect the results. So that's where logging comes in. Okay, so logging messages where? I want logging whenever we restore a tab, but not restore its content. Because there are two different phases. There's restoring a tab, which sends down all the history and stuff and basically prepares the tab so that it knows that it can't, like, it has the potential to have its content restored. And then there's actually the restoration of content, which is a message saying load the web page, excuse me, and then like fill in the form fields. So restore the tab, but not restore its content. We want a message when that happens. We want a message whenever we update the remoteness from remote to non-remote for the Chrome URI. We want to a message when we restore the tab content. And then what else? We restore the tab content when we update the remoteness. That's probably it for now. So let's put some logging in there and see if we can get an order of events. So we restore a tab. That happens here in restore tab. So where should I do that? I'm going to do the logging. Where's a good place? Heck, why not right at the start? I don't think we can exit. Okay, so dump restoring a tab. Okay, and then update the remoteness. We can do restore tab content next, actually. So restore tab content, dump restoring a tab's content. And I actually am interested in knowing how it got there. So stack, get the stack, dump that out. And then when we update the browser remoteness from remote to non-remote, and that will be in tab browser, update browser remoteness. If not a should be remote, dump setting browser to be non-remote. Okay. So build faster, and then let's run this test and see what happens. What order do these failures or these messages come out in? Monkey test. Wow. Oh, no. I want to run that with the --e10s flag so that it runs with our special stuff. Because if I don't, it only fails in the e10s case. Yeah, because in the single process case, I mean, remoteness doesn't mean anything. Okay. So we have our failures. And here is what happens. So the test starts. We enter the test. We restore a tab. And then we restore the tab's content. That happens because we set the tab state. That's something that the test just does. When we say promise tab state, what we're doing is we're setting the tab state and restoring the content. And then I think by default oh, I remember. I know why we're restoring it immediately. We restore it immediately because by default in tests we do not demand. Where is it? Yeah, we set restore on demand to false. So actually the behavior of restoring on demand is not what the test expects. The test is expecting that when we set the tab state that we restore the tab immediately. So that's what's going on here. So we restore the tab's content, and then we say we're restoring another tab, and then we set the browser to be non-remote, and And then we restore the tab's content. What does that tell us? Set the browser to be non-remote. There are 2 tabs being restored here. And is that what we expect? We open up a tab. We promise the tab state. Maybe we should make it more explicit when we adding the test tab. Here. So let's do that again. Ooh, my hand, all transparent. Cool effects. Cool effects. Whoa.
Mamma mia!
Alright. So we add the test tab. That causes us to restore all of this stuff. Yeah. Okay, so we restore to about blank. No, we start with the tab and about blank. And then we tell it to restore its state. And the state involves us saying that, oh, you're supposed to start at this web page. And so we enter navigate and restore because we've got code that realizes, like I said, oh, the page that you're trying to go to in the content process is blacklisted. You can't go there. So you should actually go and switch remoteness and be in the parent process. And that happens all in here. So it realizes that we need to do navigate and restore, which is where this thing navigate and restore flush to get the latest tab state. Huh. Hold up. Restore tab. Navigate and restore, and then restore tab. Restoring tab's content. So how about, let's add some logging here. We noticed that we're loading a URI in the wrong process. Going to try to flip remoteness now, because that's what that does. And I know this might not seem very exciting, but this is how I pick apart the test failure. Like, what's happening? What is going on? And it's like looking at the order of events and what's expected. And I do this normally with the debugger, but unfortunately that causes the test to pass. We're restoring a tab, restoring the tab's content. That's all expected. So we talk to the remote browser at about blank and say, here, have this stuff. And so it starts attempting to load this URL immediately because we don't restore tabs on demand. Then it realizes, oh, that URL is blacklisted. Let me flip remoteness. So eventually navigate and restore is called through some messaging and magic. We notice that we're loading a URI in the wrong process. Going to try to flip the remoteness now. So then it attempts to restore the tab again. And so it tries to go get the tab state. Restoring a tab again, restoring a tab's content. And once it has the tab state, it attempts to blast it back down again. That should work. I mean, like, this should be able to get the content. This should be able to go get like the form history stuff, and yet it hasn't. Why not? Tab state flusher. How does that work? Tab state flusher works. Flusher. Yeah, there it is. When we flush, we send a message down to the child saying, yo, give me your stuff. Session store flush. And then the child will receive it down here. And then we'll say flush. And then we'll flush the message queue, send the latest updates. Message queue, send. Restore tab content. And then like flush, like form history, form data listener. That's the thing that don't collect frames creator after the load event. Can't restore the form data for these. G frame tree map form data dot collect. Form data. What's form data? It's just this thing that we can get, form data.jsm. It hasn't been filled out yet. The form hasn't been filled out yet. Because the form hasn't been filled out yet. Oh, okay. Okay. Okay, I think I have a better understanding. Here are the order of events that I think this is what's going on. 1. A remote browser is opened at about blank. 2. We set tab state on that remote browser and say that it's supposed to be pointed at a Chrome URI. The tab state is received by the remote browser and it attempts to navigate to the Chrome URI. The remote browser realizes that the content process realizes that it cannot view the Chrome URI and sends a message to the parent saying to flip the remoteness. Okay, hang on. We set tab state on say it's supposed to be pointed at Chrome URI, and we send down form data along with it. The tab state is received by the remote browser and attempts to navigate to the Chrome URI and queues up the job of setting the form data once the page has loaded. The content program can view the Chrome URI and sends a message to the parent saying to flip the remoteness, and then the parent asks the child for all of its state history. This occurs before the page has loaded and the form data filled out. That's why the form data is empty. Form data is empty. The parent receives the data, including the empty form data, and then that's why it's a race. That's the race. Does the remoteness flip and sends down the new history data. That's the race. So the race is, I believe the race is, between steps 3 and 5, the content process is holding on to the form data in some intermediary variable, but hasn't is not going to, will not remember, will not know about, will not have that information sent back up to the parent in 5 before the page has finished loading. So the form history data is lost. I think that's what's happening. And I think what I have to do in order to like confirm that is to look and see what happens whenever we ask the content process to like remember form data or load form data. So we say restore history with all this tab data and stuff, and that goes into content restore. That's down here. Content restore says, okay, I will restore history, right? I'll restore history. And it sets the tab data to this like local thing. And then what do we do? Add a progress listener to correctly handle browser load URI calls from foreign code. Okay. Notify the parent when the load started. Session history. We get the tab data that we'd stashed up here. Wait for the tab load to complete or fail. And in the finish callback, form data. History listener, we set all this stuff up. When we finish restoring the tab by filling in form data and setting the scroll position, form data is this stuff. And then like restore tree. What am I going to log here? Restoring the form data. And then let's see what it looks like. Form data, JSON, stringify, form data. I'll print it out nicely. I'll put that after here. And then what do I want to do? Collection. When the collection occurs, that's the other thing. Content restore. So content here in restore history. Unload finish. Dump. Restoring of tab content has started. Dump. Restoring of tab content has completed. Dump. Restoring of tab history has completed. Restore tab content complete. Dump. Restoring of tab content was requested. Dump. Restoring of tab content was completed. Flush the message queue and send the latest updates. So that's in the message listener. What about the form thing? Form form data listener, collect gframe tree map form data dot collect gframe tree map form data dot collect on frame tree reset. So handle event change form data collect dump form data was collected, looks like, and then that JSON.stringify that null. Wow. There we go. And then what's going to happen? Then in session store, let's take a look at what we get back. Tab flesher. We'll look at the tab state. Dump. Flipping over remoteness with this tab state. JSON.stringify. Null. Tab state. Null. Okay. And that should, I believe, be enough to confirm my suspicion of the race, where the race is. Okay, let's see. Okay, so we got our failure, and what happens? Restoring the tab's content, and then restoring if tab history was completed, restoring if tab content was requested, and then when we're starting to restore the content, we notice that we're loading a URL in the wrong place, going to try flip remoteness now. Flipping over remoteness with this tab state. So when we flush, tab state flusher was supposed to send this flush message. Flush. This flush. Message queue send. Flush the message queue. Message queue. What is this message queue business? Message queue. Flush. It's important to always send data. If there's nothing flush, the update message will be received by the parent process that can update slash. So it's not that we just never like have any form data to send up. That's the problem. Huh. Okay. Excuse me. Okay. So now that we know this, what do we do? How are we going to fix this? Well, hang on. I want to do one more thing to confirm this, and that's to let's see. What will I do to confirm this? Tab state. I'll do it in session store. I'll make it so that we'll do this flush after a timeout. Window.setTimeout, and then we'll run this whole function. We'll run it after 5 seconds. That's a nice amount of time. That's a big long wait. I'm not going to bother with the indentation. If this passes, then I'm right. And that's where the race is. Let's check it out. How we doing? Wow, wow. 2, 3, 4, 5. Interesting. Not what I expected. Not what I expected at all. We noticed. Trying to flip remoteness now. Is it because the... Oh, hold up. How does this navigate and restore tab thing work? Navigate and restore happens when we call load another process, which happens when we have redirect load called on us. Flags, redirect load happens whenever we see the browser load URI message come up. And the browser load URI message is sent when send message, send async message, redirect load. Target to the correct process. Maybe that's where I should put the set timeout, actually. I think I put the set timeout in the wrong place. Although, it's weird. I would have thought that... Like, what is that tab doing? Let's run that again. Let's run that again. This is good. This is... I know it seems like I'm just kind of floundering and just poking around, but I'm learning. I'm learning how all this kind of ties together, which is very important. So notice that like we've... It says that the restoration of tab content was requested, and then it says that the restoring of tab content was completed. But it probably failed. You can't load the Chrome URI. That's the other reason. There's no document. It's not that there's no chance of... It's not like we didn't wait long enough to load the Chrome URL in the content process. It's because we couldn't load the Chrome URL in the content process. So there's no data to get. Because that's an impossible thing to load down there. You cannot load that URL down in the content process. Okay. Okay. Actually, to be more specific, it's not that it's a race. So then how come it sometimes worked? Like, where was the race? Actually, now that I think about it, I don't think it's much of a race. Since the content process has no chance of filling in the form history stuff because the URI cannot possibly be loaded in the content process. So it's not possible to read the form in the content to persist history. It's not possible to load that page. It's not possible to load that page. So we do this remoteness flip. There is no race. There is no race here. There is no race here. Okay, that's good. I like determinism. There is no race here. At least that's my current hypothesis. Okay, so good. We did learn something. We learned something useful. There's absolutely no chance of getting the right form data. We could potentially... potentially fix this by having hold up. So hang on, how does that redirect load stuff work again? Browser load URI is fired. E10s utils can load and redirect load. E10s utils redirect load. Who calls that? In here and in here. Later. I don't want these updates. Not right now. Oh, it's a security update. I'll do it later. I can't do a restart right now. This is not the right time. Should load URI in browser. This is only in the parent process case. In the content process case, check with. If we shouldn't, then we do this redirect load. Should load URI so it doesn't load the URI. Should load URI. Should load URI. Because we're implementing web browser. I determine whether we should the load should continue. Doc shell. We're down in doc shell. Should load URI. Yeah, right here. Right here is where it happens. We check to see whether or not we should block the load. We do. So we don't actually load the page. We don't actually load the page. We would just return NSOK and don't actually load the page because this will cause us to do a remoteness flip in the bad case. That all will result in us sending some messages to do some stuff. So maybe what we need to do is in this like content restore tab data thing. It's tab data. Store history. And then we say restore tab content. We load the URI. And then store tab content. Store tab content. Listen to progress. When does restore document get called? Who calls that? When the page is finished loading, a load event will trigger in contents restore, which will call restore document. Huh. So one thing we could do is we could make it so that when we ask the content session store for the form data, flush the message queue. Oh, it hasn't been sent to the parent process yet. Message queue. What messages do we send up? Data. What's this thing? This data get key. This data get key. Last updated. Options object sync to send data to the parent process. Flash to switch. This is a flash. It's file. The file message sent on unload. For the update ID used to accumulate data to send. There's this data map, a map holding lazy closures of all queued data collection routines. These functions will contain data collected from the doc shell. Right. So then we call it, we actually call these collector things. So for example, for form data listener, we'll call collect. Content restore. So much state. Wow. Content restore. What is that? So G content restore. Right. Whoop. Yeah, remove progress listeners. G content restore, restore document. Like, what if the form data listener, we did this instead of form data listener. What push. Set key create lazy and then the function. So message queue push history, message queue scroll, message queue push form data, this collect. And we never do this. We never do this. Okay. I am gaining understanding by having content session store fish out the basically the aborted form data that we were going to restore with out from the content process. Right? That's why. Load your eye with options. Okay, so right, so that's one potential fix for this one, this one test failure. Is that the problem? Like, is the same problem what we're running into with these other test failures? How many other test failures are there? 615394 is also a problem. Backslash plosion. Is it the same problem? If it's the same problem, that's useful. That's useful information to know. So let's take a look at some of these other failing tests, and let's see. Let's look at these other failing tests to see if they're hitting the same problem of attempting to grab form data from a unrestored URI that cannot be loaded. From a restored URI that cannot be loaded in the content process. So backslash plosion, what does that test do? This is also a pretty small test. Oh, great, a summary. So we'll open about session restore where form data is a JS object, not a string. Check that the session data on the page is readable after JSON parse. Check out that there are no backslashes in the form data. Check that form data doesn't require JSON parse. So what do? We create an about blank tab. We get the browser. We wait for the browser to load the about blank. And then we set some state. The state is create entries. Oh man. To go to a non-remote, so it's the same pattern. Go to a non-remote URI with some form data. And then we check the state. Yeah, this is the same problem. And I'll bet we can make this pass again if we make about blank a instead of using about blank, use something like about robots. I'll bet this will pass. The reason that'll pass is because we won't have that transition from remote to non-remote. We'll just have this non-remote page going to another non-remote page. And I'll bet you that will pass. I will bet you 1 buffalo nickel. I don't even know what a buffalo nickel is. Components, session store, test, that, E10S. Drum roll, please. Hi-oh! Yeah, that passes. And let's look at this last test. Browser, what's its face? Same thing? Oh, this is a harder test to read. So let's take a look at what the failures were. Window state test events, undefined assertion name got 2, expected 1 on line 102. Here is busy event count 0 on SS tab restored. Busy on SS window state busy. So we add these things, and then we expect certain events. I see. Busy events. When is SS window state busy fired? Set window state busy. Send window state event busy. And I guess we don't do that. Got 2. Oh, we got 2 of them. We got too many. Too many busies. Why is that? Why did we get too many busies? Well, when do we window state busy? That happens when we restore a window, and also when we restore a tab, because the tab is restored twice. Is that why? Okay. And the same thing goes for got to, expected 1, and then another failure, got to, expected 1 for line 103, and that's this other counter, the ready event count. We expected 1 ready event, we got 2. And then another one on line 231. Again, busy count, and then 232, ready count, and then 292, 294, busy count, and ready count. And then 353 and 354, I'll bet it's the same thing. 353, busy count and ready count. We fire them too many times. And then 354, yeah, ready count. So that's the reason. And if I were to just like bump these up, is that enough to like calm it down? I'm not saying that that's the solution I want to use, but like, are there any other failures like hangs or anything, or is this it? Is this all that it cares about? And if like we somehow figure out how to not fire these so many times, is that enough to put us in a good state? Let's find out. So, this test is here. Oh, and then 463.205. There's another one on, oh, browser broadcast. There are a couple of other failures in here. Oh boy. Oh, I need to do that. And why would my patch change that? Got 4, expected 1, got 1, expected 2. I don't even know. Got 4, expected 2. Where am I at? Is it just logging? It was just logging, was it not? Yeah. And we bumped up some counts. What's going on? Okay, so let's revert the changes there. Let's try that again. A lot more failure. 4, expected 1, 4, expected 1. Oh, there were a couple where I probably filled in the number wrong. Yeah, they're in here. I was too, wow, we're firing 4 instead of 1 on, what, 354 on the ready event count. We're ready 4 times. Why is that? Good question. Browser components session store test browser.ini ss window state. It's supposed to work, but for now, if I put that line back though, like if I, what was it? in here, update browser remoteness. If I get rid of this brace, is that enough to make it happy? Is this also the culprit for this case? Or is it something else entirely? Let's see. Yeah, that's what's causing it. That passed. Oh boy. Oh boy, oh boy, oh boy. Oh, because when we don't update the browser remoteness initially, that will cause us to do it on the fly. We'll be restoring twice. That's why. We're increasing the amount of times that we're restoring all these tabs. Okay. Okay. I think I understand these failures. These failures are because we're increasing the amount of time we are restoring, the amount of times that we are restoring tabs. We restore them once to load them the first time and restore them again in order to flip their remoteness properly. Sometimes we seem to fire the ready busy events 4 times. I don't know why that is. 4 times instead of 1. I don't know why that is. Okay. What are we gonna do? What's the solution? So something I was talking to Mossip about, Mossip is someone who knows this code, is to move this updating of the remoteness and setting up of the view source browser and all this stuff that sort of, and no, you'd have to use this to send down the history. What do? We do the flipping of the remoteness as we restore, like when we restore the tab content, we make sure that the remoteness is set properly. Is that right? Yeah. Yeah, I think that was the idea. In restore tab content, that's when we update the remoteness. And that might happen asynchronously in the like restore on demand case. Okay. We flip the remoteness then, and only then. Why are we firing? Because they don't start remote. That's why. Because the browsers don't start remote, and we're flipping the remoteness on demand, that's why we're seeing so much extra activity. They don't start remote. The initial browsers are kind of these like dummy, like they will become remote. They will become remote. thinking about. I guess I'm still thinking about like the best way of approaching this problem. I'm going to see if Tim Talbert's around actually, because he and I had been talking about this earlier, and maybe he has some more ideas. And he had to go to a meeting, but maybe he's done now and maybe we can talk. Also, apparently array comprehensions are being moved from ES7? What? That's news. That's news because it's removed from the spec. What? Alright. Well, no word from Tim yet. Okay, so let's brainstorm some solutions. Like, in an ideal world, what would happen? In an ideal world, all of the background browsers that are unrestored would be non-remote, so that they can't crash. The remoteness would be flipped on demand. The tab state, let me think here. Remoteness will be flipped on demand. When the parent asks the child to flush its state back up to the parent, the child should be able to do that with things that it was. The child should be able to remember any form history for unloaded Chrome pages because the page couldn't be loaded. What? Content session store.js, when loading the document, can determine that the document being loaded is going to cause a remoteness switch. That is true. In that event, can it stuff the form data it was going to restore into the form data listener? Form data listener. G-frame tree. Content restore. Like, perhaps, so one idea, add a way for callers into add a way for things to register for on pending remoteness switch or something onto the content restore object instance, and then if before the load it's clear that we're going to be flipping remoteness to signal all of those listeners with the data we were going to restore the content with. Something like that. That's pretty convoluted. Restore the content. Restore the history. Started. This tab data is what we want. Tab data. What uses tab data? Tab data. There. Entries for restoring document. This thing. Stash away the data we need for restored document. Restoring document. Stop length. We stuff it in there. We reload the current entry, and then who does something with restoring document? In restore document, that's on page load, and we suck all this stuff out and we jam it all back in. Okay. So kind of what I'm thinking is like we attempt to load the URI. Like if we know that so get history into the same state it was before the load started, then trigger. Oh, the load has been redirected to a new process. Before the load started the trigger, then trigger the load. Load arguments. What is this? Restore tab content with load arguments. Restore tab content with load arguments. Restore tab content. No. Calls restore tab content with load arguments. Is that somewhere in here? Restore tab content. Yeah. Load arguments. Okay, back in here. A load has been redirected to a new process, so get history into the same state it was before the load started, and then trigger the load. History into the same state? What are you talking about? What even is happening here? We make a URI from the refer. We create the post data. Oh. URI flags. Post data. This is after we've loaded. This is not before, this is after. Right before we crash, I want to start that page again. When it started. We should still blank the page. Data we need for restore documents. So like in here, we could check the URI that we're about to load. And then tell form data and all these other things, scroll position, all of it. What do I want to do here? Okay. What are we gonna do? What are we gonna do? What are we gonna do? Been a lot of humming and hawing this episode, and it's 2:33. I should probably wrap it up soon. But I feel like I've learned a lot about how Content Session Store works and how all these pieces fit together. I hope you have too. This is good. I feel like I've made forward progress.
It's me, Mario.
Oh, yeah.
But the way forward is not clear. Restore tab. Restore tab. Options. Increase the busy state counter. What does that mean? What are these busy and ready things? Before I head out, what are these events? Window state busy, window state ready. What are these? There's probably some documentation. Yeah. A window state has switched to busy. Oh, so it's for add-ons. The window state busy event is executed when the state of a window has been switched to busy. When is a window busy? When is a window busy? Is this window state busy? Set window state busy. Window busy equals value. Keep the to be restored state in sync. When do we fire the busy event? Send window state event. Set window state busy. And then there's the value. Window set to the new count. New count equals 1. Huh. Oh. So we must do this. Then we must do this. Then we must do this again. Must do this a number of times. That's the problem. We're kind of flopping around. We fire so many extra events. And why do we do that? What is the point of this event? Why do we set the window to busy? busy. Keep busy state counters per window. There's a tab busy. So that's a state busy. Set window state busy. Why? What is the point? Session store, busy. There's a wiki page, busy. Is the window currently busy restoring or duplicating a tab? Okay. Okay. So, of course we increase the number of busy and ready. Okay, I think I have a plan. Here's the attack plan. Okay. Attack plan. To propose to Mossip or Tim Talbert or both. 1. In content session restore or session store, notice when we're going to flip remoteness and queue up flip remoteness on a page load and page load during content restore and queue up messages for form, data, scroll, etc. for stuff we were never able to restore before the flip. Okay, that should fix that, this, and this. You know what? We could attempt to rig that really sloppily right now just to see if I'm right, if that would fix those tests. Let's do that. Let's rig this first point. That should fix, what should it fix? It should fix, which is the test? Where is that? Not backslash explosion. It's this one. That should fix this one and backslash explosion. Backslash explosion. Let's see if that's true. And then the other idea was to update the SS Windows state events test to accommodate, to account for the fact that we will restore background tabs in E10S mode. Okay. And then we have these other test failures to deal with, but I don't know what these ones timed out. Let's see. Let's actually see if this one just like blocks right now. What's our just logging? We didn't revert. Yeah, it's just logging. Okay. Gonna revert that change to. Yeah, and then mock multi-test E10S. Okay, good. That one passes. So I suspect that it was because the previous test failures put the browser into a bad state. Whoop. How about this one? I didn't actually accidentally undo that thing, did I? Browser. Okay, good. Failed. It failed. Well, it has to do with form data, so maybe that would also fix form data. What's inside this test? Browser, form data, format. If it's not doing any OKs, that's weird. Ah. Right, we never get this, so yeah, this should probably fix that one too. Browser form data format. Okay, so let's see if we can rig up that sloppy solution just for form data in content session restore or session store. So in here, no, I'll put that back. It was down in content restore over here. The URI that we're attempting to load is entries. What's tab data entries? Something or other. We do something similar over here. Can load entries. The URI is like this. Something like that anyways. Right, active index equals tab data index minus 1. And then active page data equals tab data entries let URI. If and then what's the load another process? Load other process, or can load, what is it? Browser, JS, can load URI in process. Where is other example callers? Should load URI. Doc shell URI and refer. Refer is not actually used, but I can do this. Services app info process type. So URI, and then services app info process type. If not that, we're going to flip remoteness. So queue up form data. Okay. We'll do that down here actually. And then this dot form data listener dot. This is a really sloppy solution. Content set form data listener Form data, handle event, inject is what I'll call it, and function data. Message queue, push, form data, data. Okay. Inject. And then what I'll do is on init, I'll say gcontent restore dot form data listener equals this, like really sloppy now. And then this thing will call inject tab data, form data. Okay. Meanwhile, people have messaged me in IRC. I don't know who those people are, but I'll probably get to them after this episode. Yes, I will get to them after this episode. Okay, so let's see what happens now. Does that fix the test? Let's find out. That's a good one to run. Let's run this old one. No guarantees. Haven't actually like manually tested this, so who knows what's going to happen. There are things that it's possible that, yeah, there are things that are not defined, like e10s utils. E10s utils. E10s utils. E10s utils.jsm. That's the one. Just wholesale copy that. Whoop, whoop. There you go. Services is also not defined. That's surprising. Services is usually defined. Define lazy module getter. This services. GRE modules. Services.jsm. Yeah. Okay. It's gonna happen. Form data listener is undefined. Content restore. So form data listener is undefined. Must be doing things in the wrong order. Init gcontent restore form data listener init form data listener is what I called it. Initting form data listener gcontent restore return new gcontent restore this, then gcontent restore Chrome global What? Well, perfect opportunity to use the debugger, I guess. JS debugger. Whoops. Let's see. Oh, no, I need to profile the content, or I need to get the content toolbox. Content process running. In a new window, maybe. About home. There we go. And then browser. No. Content session store. And then in no, restore content. Content restore. JSM. That's the one. We'll set a breakpoint in here. And then in content session restore, form data listener, we'll set a breakpoint here. And now let's run the test. Where is the debugger? Utils is not defined. What? On content restore line 208. That all sounds horrible. What's going on here? Oh man. It's all kind of broken. All kinds of broken. What's happening here? Start, and then in content session restore, in restore history function is not extensible. Line 400. Contents is not extensible. Oh my, that's what they did. They don't want expandos. They are freezing it. Okay, that's what's up. Restore. So how about this? Set form listener, and then this dot form data listener equals listener. I'll call that form data listener, set form data listener, and then over here in content session restore, instead of doing this injection, we'll do set form data listener and call with this. Right. Righto. I'm not exactly sure why my content toolbox went away just when I needed it, but it did. Now what? Now what? Oh, that's just bad coding. Content restore is missing a closey brace on line 126. Of course, I need a comma here. That's just sloppy. Alright. Go, 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 go. Fly, my pretties!
me, Mario.
Damn it. Oh, but look. Restoring the form data. Restoring a tab. Restoring a tab's content. Restoring of tab history is completed. When do we flip the remoteness? What's tab state? Where does the flip remoteness thing occur? Destroying the form data. Tabs content. Entries. So we try and flip the remoteness here. And form data is not in there. Restoring a tab's content. So let's do this bit. Let's do some more logging. More logging. Restoring tab content in the content script now. And then testing to see if content restore is testing to see if URI can load in this process. Dump. It cannot. Injecting form data. Okay. I'm a rocket man.
Hi-oh!
Come on. I need a win here. Give me a win. Okay. So, restoring a tab's content. Storing of tab history is complete. Restoring a tab content was requested. Restoring tab content in the content script now. Content restoring is testing to see can load the content process. It cannot connect. Injecting form data undefined. There is undefined form data. That's why. Form data is undefined. Oh, because I've got a uppercase D. It's the little things that'll get you. The little things. Casing. Hey, that worked.
That's right!
Oh yeah. Oh yeah. Oh yeah.
Now, in terms of implementation, that's a terrible implementation. Like I would not even think about requesting review for that. But I have an idea now of a solution for this bug, and like I think that'll fix the other ones as well. What was it? Browser /explosion? What was it called? Browser etns. Okay. Fixes that one. And then this one, I think. So this little fix, this approach to the fixing the issue, fixes those tests. Okay. This does work. And potentially we might have a solution here. Okay. I'm going to go talk to Mossip and Tim Talbert and see what they think of this. Maybe they have better ideas, but I have an idea. Like, we have a potential solution. We certainly know what's going wrong now, and that's half the battle, really, is knowing where things are going wrong. So I actually feel, although we didn't end up writing a whole lot, it's one of those episodes where it was just a lot of thinking and figuring out and reading and organizing, and then coming up with potential solutions and brainstorming, and then confirming hypotheses and approaches. And now we have a potential approach. So now it's all about making sure it's the right one, talking to the people who know this code really, really well, and we'll be in good shape. Folks, I think that I'm going to call it. So, let's see here. Thank you so much for watching episode 31 of The Joy of Coding. This has been illuminating, this episode. I wanted to let you know that if you want to talk to me at all during any of these episodes, during the episodes, I'm hanging around in IRC on the hash #livehacking channel on irc.mozilla.org. There's a link in the agenda to a web-based IRC client that you can use to talk to me, and I'd love to hear about any ideas you have. You know, like maybe you're watching the video and you're thinking, oh man, he's not even considering this potential solution. Chat with me and talk to me, and maybe we can figure some stuff out together. Just put my name, whenever you talk, put like mconley, that's my IRC nick, mconley before anything you say, and it'll like bing, and then I'll see what you're saying. I'm not the only one doing live stuff at Mozilla. Ricardo and Joel Marr are doing 2 other shows. There's Lost in Data. There are only a couple episodes, but it's very, very fascinating. You can watch someone triage performance problems with Firefox Desktop, and that's Lost in Data. And then there's the Hour of Design, where one of the Mozilla Foundation designers shows you his process. Both of those are great shows, but we really need some more shows. So if you're out there in the Mozilla community working on stuff, come talk to me, and maybe we can set you up with a show. I think it would be great to demonstrate to the outside world, outside of the community, what it is that we do inside of the community. And yeah, come. It's easy. It's pretty straightforward to set up the software, and I can help you. And Richard in the #livehacking channel, we can show you how it's done. And I think that's all I want to say. Feel free to reach out to me on Twitter. I'm at Mike_Conley on Twitter. And I'm mconley on IRC, and there's a link to my blog, etc., in the agenda. And I think that's all I want to say. So thanks again for watching episode 31 of The Joy of Coding. I will see you next week. Take care.
The joy of coding.
Bye.